Consider the case of a field researcher standing waist-deep in a murky, humid swamp. After spending months securing grants, enduring grueling travel, and tracking a highly dangerous predator through the underbrush, the scientist finally has a wild crocodile exactly where she wants it. Her goal is simple. She needs to attach a vital radio transmitter to the animal to track its movements. She carefully reaches out, applies a specialized, fast-acting field adhesive, and in a single split second of miscalculation, accidentally glues her own bare hand directly to the scales of a living, thrashing apex predator.
This highly stressful and completely absurd situation actually happened to researcher Agata Staniewicz. It is the kind of story that rarely makes it into published academic journals, but it perfectly captures the hidden reality of scientific fieldwork. We are conditioned from a very young age to view the pursuit of human knowledge as a clean, orderly progression. We imagine sterile laboratories, pristine equipment, and flawless geniuses moving smoothly from a hypothesis to a groundbreaking conclusion. But look closely at the actual historical record of how we learn about the universe, and you will find something entirely different. You find a process that is profoundly messy, repeatedly embarrassing, and chaotic.
Why do our most rigorous, expensive attempts to measure reality consistently devolve into cartoonish disasters? And more importantly, what is this endless string of embarrassments actually teaching us about the natural world? The first major hurdle in any scientific endeavor is the simple, unavoidable fact that the environment does not care about your methodology. The physical world is aggressively hostile to being quantified. In the Canadian Rockies, climatologists meticulously planned an expedition into Banff National Park in May, fully expecting the mild spring weather typical of that season. Instead, they were completely snowed in and trapped by a freak unseasonal blizzard, forcing them to abandon their meticulous data collection just to survive.
Extreme environments routinely short-circuit both advanced technology and basic human logic. In the sub-zero temperatures of the Arctic, a highly trained glaciologist leaned in too close to a metal coring drill and accidentally got their tongue frozen solidly to the frigid steel. It is a classic childhood playground mistake, but it happened in a high-stakes, incredibly remote environment, proving that intense physical fatigue can easily override a doctoral education in thermodynamics. Sometimes the danger comes from a hyper-focus on the data itself. A dedicated meteorologist, desperate to capture atmospheric readings, once walked directly into an active thunderstorm carrying a 10-foot-tall metal aerial antenna. In their obsession with the experiment, the scientists temporarily forgot the most basic rule of survival and accidentally turned themselves into a walking lightning rod. But environmental hazards are nothing compared to what happens when the subjects of the experiment possess their own agency. We often approach biology with a deep, unrecognized arrogance, assuming that animals will passively participate in our studies. The wildlife violently disagrees. In the dense jungles of South America, one researcher attempted to test the marking behaviors of local predators by urinating on a tree that had just been scent marked by a wild jaguar.
The scientist was trying to establish dominance or provoke a measurable territorial response. The response they received was the jaguar silently stalking them through the jungle for 3 weeks. Wild apex predators do not care about academic credentials. Even less lethal animals actively sabotage human engineering. Primatologists attempting to observe wild monkeys frequently find their roles reversed as the highly intelligent primates coordinate to steal research equipment, suitcases, and specialized tools, effectively turning the scientists into the confused subjects of an entirely different game. In the ocean, marine biologists deployed a massive, multi-million-dollar autonomous underwater vehicle to map the seafloor, only to have a territorial shark immediately attack and severely damage the incredibly expensive machine. Sharks simply view advanced robotics as either a physical threat or a crunchy potential meal. Cephalopods are equally disruptive. Researchers have placed heavily weighted underwater cameras on the ocean floor to capture subtle crab behavior, only to watch helplessly as an octopus realizes the camera is a movable object, wraps its tentacles around the housing, and swims away, effectively stealing the equipment to film its own high-speed chase across the reef. If you have ever experienced an animal completely ignoring your carefully laid plans, drop a comment below and let us know what happened. The chaos of discovery is not limited to the wilderness. Even in highly controlled technological environments, human error manages to manifest in spectacularly expensive ways. In December of 1999, the National Aeronautics and Space Administration, widely known as NASA, lost contact with the Mars Climate Orbiter. The spacecraft was a $327 million marvel of engineering designed to study the Martian atmosphere. As it approached the red planet, it dipped too low and either burned up in the atmosphere or was flung wildly into deep space.
A rigorous investigation revealed the culprit. The navigation team at the Jet Propulsion Laboratory had calculated the spacecraft trajectory using the metric system, specifically measuring force in newtons. However, the private contractor that built the software had programmed the thrusters using imperial pound-seconds. Nobody caught the unit mismatch. A multi-million-dollar interplanetary mission was utterly destroyed by a fundamental conversion error that every freshman engineering student is taught to check for on their very first day of class.
Sometimes the technology works perfectly, but the human interpretation goes wildly off course. At the famous Parkes Observatory in Australia, astronomers spent weeks tracking a series of strange, localized microwave signals appearing to come from deep space. These intense bursts of energy, dubbed peritons, completely baffled the astrophysical community. Researchers debated whether they were witnessing the evaporation of distant black holes or the collision of neutron stars. After a grueling investigation involving highly sensitive tracking equipment, an observatory staff member finally cracked the code.
The signals were not coming from the cosmos. They were emanating from the facility breakroom microwave. Whenever a hungry scientist prematurely pulled open the microwave door to check on their lunch, the machine released a brief, localized burst of radiation that the massive radio telescope picked up perfectly. The grand mysteries of the universe were actually just the sound of a hastily heated meal. This brings us to the deepest and most consequential source of scientific failure, which is our own psychological bias. The human brain is desperately wired to find patterns, and sometimes it finds them even when they do not exist.
Consider a team of archaeologists who spent days painstakingly excavating an ancient burial site. They celebrated as they brushed the dirt away from what appeared to be rare, striking bone fragments. Driven by the thrill of discovery, they dug just a few inches deeper, only to unearth a brightly colored Kentucky Fried Chicken wrapper. The ancient historical site was nothing more than a modern trash heap. It was a harsh, embarrassing lesson in the necessity of strict stratigraphy and the ever-present danger of confirmation bias. We see what we desperately want to see. This same confirmation bias can infect entire generations of brilliant minds. For decades, the entire 19th century physics community was obsessed with finding the luminiferous ether.
Because sound waves require air or water to travel, physicists assumed that light waves must also require a physical medium to travel through the vacuum of space. They spent enormous amounts of money and time designing beautiful, complex experiments to measure the invisible ether wind. They failed over and over again, simply because the ether does not exist. Light does not need a medium. The entrenched paradigm forced thousands of scientists to spend their careers aggressively chasing a ghost. Even the greatest minds are not immune.
Albert Einstein famously introduced a mathematical fudge factor called the cosmological constant into his equations of general relativity. He did this for one simple reason. The prevailing assumption of his era was that the universe was static, neither expanding nor contracting. His raw math suggested the universe was dynamic, but Einstein allowed his aesthetic preference for a stable, elegant universe to override his own empirical equations. When astronomer Edwin Hubble later proved the universe was actually expanding, Einstein realized his mistake, later referring to the forced constant as his greatest blunder.
When you put all of these hilarious, terrifying, and embarrassing stories together, a profound pattern begins to emerge. Science is not a rigid, magical truth machine. It is a chaotic, grinding mechanism of elimination. We build elaborate, autonomous robots to patrol our cities, only to watch them fail to detect a decorative water fountain and drive themselves directly down a flight of stairs to drown in 3 inches of water. We launch expensive satellites that burn up over bad math. We get chased by jaguars, swarmed by angry bees, and fooled by microwave ovens. But these disasters are not evidence that the scientific method is broken. They are evidence that the method is working exactly as intended. Every single time a researcher glues their hand to a reptile, or a machine fails, or an accepted theory like the Aether is shattered, we are forced to drop our human arrogance. We are forced to admit that our preconceived notions about how the world should operate are wrong. The universe does not care about our aesthetics, our comfort, or our academic prestige. It simply exists. The continuous stream of scientific embarrassments is the necessary friction required to slowly grind away our biases.
By ruling out all the things that are false, no matter how much it bruises our ego or our budgets, we are eventually left with the strange, beautiful, unyielding truth. So the next time you read about a high-tech experiment failing spectacularly, do not lose faith in the process. Just remember that the road to understanding the cosmos is paved with broken equipment, stolen cameras, and scientists figuring it out the hard way.